Other questions? We got lots of good questions already. How do we do PA5? Write some code, run it.
Submit it.
Yeah.
That's the report.
That's
part.
yeah.
I got PA5 working, I think.
Cool,
for the
awesome.
most part.
Have you hooked it up with anybody else's code?
I've hooked it up with, I have a virtual machine, so I've done my Windows machine and then the virtual box as well.
Oh,
Works
cool.
That way, but I don't
Okay.
know if that's like over the internet or not.
It's over something, it might be a virtual internet. Cool, yeah, so when you get the stuff working, find a friend who's got another piece of it working and see if you can get it talking to each other. Right? It's not required for PA5, but that makes it even more fun.
I'm a little confused about how to break the communication though, because Control-C seems to work just fine.
Yeah, but then can you reconnect?
I haven't tried reconnecting.
Okay, so you got to be able to end the session and then start another session
Okay.
and have that work.
And the server doesn't shut down.
Yeah, so if the server doesn't shut down, if it's threaded, you might be able to start another one, but you're going to have resource leaks. So this is potentially tricky, right? And one way around this is just to insist that there's an exit command for the client and have the exit command somehow send something peculiar to the server that says, hey, shut down the connection. And that can be straightforward or complex. For example, you could say, if you get the message, quit, right? Then you should shut down the connection because the client is exiting. But of course, if somebody types the word quit, right, that triggers your secret phrase and the program exits and nobody knows why. So you might make it something weird like this, right? But that, you know, could be something you type. So you might want to send a non-printable character, something that they can't type, some weird ASCII code that they're not going to accidentally send. And so have a quit option for the user, and when they trigger that option, have it send the magic sequence of characters to shut down. If you just Control-C, so this is client, this is server. If you just Control-C over here, then this end of the pipe breaks, right, the socketed connection. And on the server side that's sitting here, you've got two threads over here. You've got one that's reading from the client to standard out, one that's reading from standard in, sending to the client. This will probably come back right away and say that it found end of file or maybe an exception. So figure out what this is doing when the client closes, and then have that send a message to the server somehow saying do something. And this is sitting here trying to read from standard in, so it's blocked, right? It's sitting in a has next line on standard in scanner. So one thing you can do, this is called changing the problem or engineering the problem, is when you detect that the client is exited, print out a message saying client exited, hit enter to continue. And that enter gets picked up by this thread, and then it allows it to go on and check a Boolean flag that was set by the first thread saying go ahead and exit. So that's one way to deal with it.
Do Control-C and Control-D both send null?
Control-C terminates, so it will end your process and it's done, right? It'll close down, it'll close your resources, so it'll close your end of the socket, but if you send something and didn't flush it, it may not get sent, and it won't actually send anything through the socket, it'll just close the connection. Control-D, if you're on Unix and you're reading from something like an input stream, will cause that to return false when you say has next or has next line. But if you actually read it in some ways, it might come out as a null. Yeah.
So the way you did it, weren't you sitting in a while loop inside of a bigger while loop, and that smaller while loop says while has next, and so if that was to cancel, that wouldn't have next, right? And then kick out of that while loop,
Right.
and go back to looking for a connection.
Exactly, yeah.
And that would work, right?
That would work. The problem is you've got two threads over here on the server side, and you want to try to shut them both down. right? One of them will know that the socket closed, and it will kick out of that while loop. Then go back to waiting for more connections. But it created a new thread to read from standard in on the server side and send to the client. And you want to shut that down somehow if possible. So these are nuances, right? And it's actually a fairly tricky process to get just right.
Couldn't you set a flag from one to your other thread?
Mm-hmm.
And then,
but you got to get that other thread to look at it.
so while it has its own while loop, you add another condition inside of that while loop to also be checking that flag?
Yeah, but that while loop, right, so this is saying read standard in, send to the client. So this is the new thread that was created, right? So I'm gonna open a scanner. Right. Well, the problem is most of the time this thread is sitting inside this has next line method. It's waiting for the user to hit the enter key. And if you want to terminate this thread while it's sitting inside this has next line, it's pretty hard to do. Because in here we can say, you know, if done, then return. But you got to get that line of code to execute somehow.
So if you had a while it has next and something else, it would still be sitting in the has next portion of that?
Yeah, you could say, well, has next and not done, but it's going to see if done is true, and if it's not, then it's going to check to see if
So
has
still
next is
sitting
true.
in,
Yeah. Now this is really easy if you're using swing, right? Because swing, you're not blocking in code. You've got something that, you know, you type in something, when you hit enter, it runs some code, and nothing else is happening. So you could have something which sits there and sleeps for 5 seconds and checks a flag, and then sleeps for 5 seconds and checks a flag. And when you set that flag saying we're done, it'll notice it's done and shut everything down. So it's pretty easy with swing. But when we're doing this, right, we're basically doing these blocking reads.
When I brought my code over to the swing class, I accidentally left a while loop in there.
Oh yeah.
And so I had an action listener in that while loop. And so when I clicked one of the buttons, it just froze.
Yeah.
It's just calling that same action.
Right.
Over.
Yeah, it'll get really weird if you block too long in swing, because lots of things don't happen until you can release your current thread and they can take over.
Yeah, I've learned a little bit about that.
Cool. All right, other questions? All right, let's play with Android. Android Studio. So, Android development. So, Android uses basically Java as its primary language. And if we get things set up correctly and we get rolling, it's going to look similar to what we've been doing with Eclipse and with Window Builder and with Swing. Okay, drag and drop, connect widgets to actions, set up properties, things like that. But there's some details that can be maddening to try to figure out. So I want to go through sort of a start to finish example of just creating some very basic apps. Click a button and display a message in response, that kind of thing. Enough to get you on the air so that you can start using what you know about Java to like work in an Android environment. And when Android first came out, well, when I first started using Android at least, which was several years ago, there was this thing called Android Studio. And it was big and clunky and it was kind of annoying. But there was an Eclipse plugin you could use for Android development. So that's what a lot of people did. You just downloaded this plugin and you could sit in your familiar Eclipse environment, but it knew about the things that you need for Android. And then that got really slow and big and buggy and painful to use. And I think Google finally abandoned that, and now Android Studio is the way to go. And it usually works pretty well, at least for some cases, but there are definitely cases where it's very annoying. And it seems to be a moving target somewhat. So for example, I had all my code working back in March, and I dusted it off last week to come in here, and none of it worked anymore. So, and it was complaining about wanting to upgrade this and change the version of that and so on. So in my case, I basically just started a new project and just copied and pasted the code, and everything came up great. So there's a million details to Android and Android Studio that I'm not familiar with, and that I never really intend to figure out, right? My goal is always, how do I make this thing do what I want to do? And I'm learning just kind of enough to do that. So that's what I'm going to try to give you here is enough to get you going, and get you to where you can start Googling documentation and have it be meaningful. So I'm on Linux, and Studio is supported under Linux, so I downloaded it and installed a bunch of stuff and followed some instructions, and I made myself an alias. Studio just runs this shell script, which I don't know what exactly is in here, but it's stuff, and I have faith in it. So, and there's IntelliJ on the bottom. So I'm just going to run Studio like this, and this will get things going. And I'll throw it in the background. So first comment, well, it's not my first. Next comment on Android Studio. It is very slow, particularly the first times that you do something. So the first time you run Studio, it's going to be a really long process, okay? When you start it up, it's a really long process. The first time you compile a project, it's a very long process, but it seems to do a reasonable job after that, okay? I don't have a super powerful laptop. It's a Amazon special, but it does a reasonable job, and most of the time that you're spending is not based on the length of your code. At this point, it's just background stuff it has to do. But once we get it compiled once, we can make changes, recompile, and it's seconds instead of minutes. But we'll let this boot up. And while it's doing that, let me make another comment, which is that Android is a very different kind of operating system from Linux and Windows and OS X. Okay, most operating systems that I've dealt with are basically a few things: a file system, so you can store information, an interface to devices, keyboard, screen, internet, etc., and fundamentally a way to run programs. So Linux, you type in the name of your program, vi blah blah blah. It searches the file system, finds a file that contains the executable code for your program, dumps that into memory, points the PC at it, and now it's executing your code. When that program exits, you Control-C, or it hits a final return statement or something, it goes away, and you're just executing the operating system code, which is usually waiting for you to type in a command or click on something. So normally the operating system is running, right? And we're used to this view of the world. We can say top. And there's a few programs that are running. Cheese is a display, Kazam is recording, Xorg is managing the window. But mostly there's not a lot going on, right? And the state of all of these things is sleeping. The R's are the things that are actually running. The top command is running, right? That's this display here. But mostly it's just kind of sitting idle. Okay, Android is a different sort of beast. And so we talk about the life cycle of an application. This looks reasonable. Yeah. So
we were trying to come up with good models for our design.
Okay.
We're kind of weird about application models. We don't know how to do them. So.
Oh, okay. Let's see, this one this one's a little better job. All right, so your activity starts, your application is an activity, right? It starts, and in the beginning of it, it's going to call this Oncreate method. Now, I don't know if this is 100% correct, but the sense I've gotten is that your apps are created when your system boots, okay? All of the Oncreate methods get called. And so you put very basic initialization into that code. And then when you start it, I believe that's when you click on the icon, right? And it comes to the screen. So the onStart method is called, and you put the things in there that you want to have happen when the person's actually running the application. And then it always calls onResume. And after that, the application is running. So it's typically sitting in the forefront of your display, and it's doing whatever it does. If another activity comes in and takes over the display, right, you click on something else, for example, your application pauses, and it calls the onPause method, and you can put code in there that saves information and so on and so forth. If you bring that application back to the foreground, right, it comes to the foreground, it comes back here and calls your onResume again. So you can use these to sort of toggle what your code is doing based on whether it's the active application or not. When it's no longer visible, right, that calls the onStop method. And if you bring it back to the foreground, it'll call onRestart and start. And if other things need memory, right, it can come over here and it can kill the process. And then your program's actually not running at all in some sense. And then if you come back to the activity, it'll call Oncreate again. So when you select all of your apps and you see the list of those and you swipe to the side to make it go away, right, you're actually killing the process. The reason that Android, at least originally, said you should not be running memory managers is because it circumvents what Android's trying to do with all of its process management, right? It's trying to keep these things ready to switch into the start or resume state without having to recreate them, but doing it in a way that hopefully doesn't consume all your resources. Every time you kill a process, when you want to run it again, you've got to go back through the creation. So it's trying to handle all of this stuff for you. And then if you destroy it, right, it goes down to shut down. So with that in mind, let's play with Studio. So we're going to start a new Android project. And what should we call this? A what? Super cool project. Okay, I'm going to start with an A so that it shows up at the top of my list of applications. Company domain, right? If you're not putting this out on the Play Store, this can pretty much be anything that you want, but usually the last part of this is some ID that's unique to you. So if you have your own URL, it's that URL, and the stuff before it is up to you. It's stuff that identifies this particular application.
You can leave that blank, right? Because from my
I don't
experience,
know. I'm afraid to.
If you put something in that, it's gonna, like your project, it's assuming that you have multiple projects under the same banner, under the same sub-project and all that stuff, and it's gonna build this giant hierarchy of folders for you.
Yeah, I would
It's
leave
kind
it
of
there.
annoying when
My concern would be if you leave it blank, things may start getting munged together, particularly if you load more than one on your device at a time. So I would leave it there. Project location is just a location. I'm going to leave everything else default. So form factors, right? So you can develop for phones and tablets, for Wear devices like smartwatches, Android TV, Android Auto, Android Things. Okay, so I'm going to go for phone and tablet, and we're going to use my totally rockin' Samsung 3, which is running Android version 21. So we're going to go with Lollipop. And this is, in my experience, really hard to change inside a project. If you developed under the wrong version and you want to change it to a different thing, I've never figured out how to do that. Make a new project, copy the code over. So I'm going to set it to 21. It's a conservative number.
And if you make it the newest version, then it's hard to test on anything.
Yeah.
Because not everything's being pushed to that version.
Right. and you got to make sure everything's up to date. So different kinds of activities we can create. I'm going to use the only one I've played with, which is an empty activity. And activity name, we'll just call it main activity. That's the name of the main class. Well, let's call it something different.
Super cool main activity.
How about super cool main class? I don't want to make it too long. Super cool main class. All right. And we'll say finish. And then we're going to go get a cup of coffee, and we're going to hang out for a while and come back when this is finished. So this part will take a couple of minutes, typically.
So basically the perfect time for you to go.
Exactly, yeah.
Mine just started.
Well, you may have a better laptop than me. So meanwhile, I'm going to plug in my device.
This is also the helpful thing, is to have any kind of phone.
That is Scooby-Doo.
I've watched a lot of Scooby-Doo in my days.
Ruh-roh.
You used to see red text in the bottom right going.
So it's an
Yeah.
But I
Alright.
still wouldn't stop watching it.
And this is a really cool phone, but I tried running it without a SIM card. And, you know, the little contacts that connect the SIM card are spring-loaded. So when I slid the case back in without the SIM card, well, that was fine, but when I took it out, it grabbed those contacts and munged them. So I can't put a SIM card in here anymore, which is sad. It's actually a decent phone, but I can still use it on Wi-Fi, and I can play with the live wallpaper and stuff. All right, so we'll let that sit there, and
My Samsung 3.
yeah.
Yeah, it just sits there running all of my online projects.
Okay, that's cool.
Because I had the same problem with the
Yeah.
SIM card.
Yeah, that's. I wish I'd known that.
Yeah, I was just like, that was my first smartphone.
Oh,
I
yeah.
started crying.
Oh. All right, so don't open it up with any of these things that your OS wants. It's plugged in right now. So when you want to work on your own device, you have to do a few things initially, and your best bet's probably going to be to Google these, because I honestly don't remember all the details. But basically, you need to go into your settings, and this changes for different versions of the system. But look at developer options and turn on USB debugging. That's like impossible to read.
Turn your phone brightness
Yeah.
down.
Turn
There you go.
this thing
There
up.
you go.
So go into settings, developer options, and turn on USB debugging. That's the main one you need here. And then the kind of goofy one is you need to go about phone. And I'm not positive, but I think it's Android version. And you have to tap it 7 times. That may not have been the one, though. Yeah, so the build number you have to tap 7 times, and then it'll say, "Congratulations, you're a developer." So that turns on developer options, and then you have that option under USB. And if you do Android version, you just get the game for that version of Android. So when you plug this in, normally it'll say, do you want to allow USB debugging from, and it'll give you the MAC ID of the device. I already turned it on by default, so it didn't ask me. But say yes to that. And now we can download things into here from Android Studio. All right, so it's created some code for us. It set up a package, okay, which was based on our domain that we specified. It's done a couple of imports for us already. We're not going to mess with those. And it's creating our main class, our super cool main class, okay? And it's an extension of app-compat activity, whatever that may be. And it's creating one method which is called Oncreate, okay? That's this thing up here. So what happens when this application is created? First thing it does, it calls the Oncreate method from the superclass. Bless you. So app-compat activity has an Oncreate method of its own. We call that. and then we're going to do other things. So we're extending that class, we're overwriting Oncreate, but we're also calling what the base class's Oncreate did. And it does this thing, set content view, r.layout, activity, super cool main class. We don't have to worry about what this means. Okay, so we're going to go ahead and run it. If you try to do this without a device hooked up, well, no, before we do that, let's look at the layout. Okay, so next thing about Android. In a lot of ways, Android apps are data-driven. Okay, in Java, in C, if we want to print the message, good morning, right, we say printf good morning, or system out print line good morning. Okay, if you're making an app and somebody in France runs your app and it says good morning and they don't speak English, right, they're not happy with your app. So what we'd like to do is, instead of saying good morning as a quoted string, we'd like to refer to our greeting and then somewhere else have an entry that says greeting is equal to good morning. And if you're in a different region, we can say greeting is equal to this other thing, right? So a lot of your Android app is actually data, and it's stored in an XML file. So over here is activity supercool main class.xml, and this is what we've got in there so far. So we usually don't monkey with this. You can, but if you mess this up, you're hosed. So we usually don't mess with it. But for example, there's some text in here that says hello world. Okay, so this gives you a sort of default hello world application, and the text is stored in here. And we can look at the design view, but it will not do that until you've actually built your project once. So we need to come over to here to run and say run app. So ADB is the Android debugging bridge. That's what it uses to communicate to a device through a USB port. And the connected device is our Samsung 545, so we're going to select that. There's virtual devices available. This is a great concept. You can click a virtual device, you can say what model, what screen size, what are the features it has, and it will create a window that looks like a phone that you can click on buttons with your mouse, and you can run code on there. It really does not work very well in my experience. It's usually really slow. It's generally very buggy. Okay, and I'm sure this is me. I'm sure someone who knows how to do this can make this work perfectly. But I have spent hours, I'm guessing you have too, trying to get the virtual devices to work. And it's just, you got to get it lined up just right.
On Windows, there's a BIOS setting you have to have
Really?
on for it. So
Okay.
I'm going to emulate something, because I think it throws the emulator on, like it borrows
Oh,
a couple threads
okay.
from the processor, and it's
Fun.
weird.
Mine sits right here forever.
Okay, yeah, that looks familiar. Right.
But
Do it on a powerful system, I guess, is my best advice.
Yeah, that can help. I mean, I've read people who said that they started a virtual device like 6 weeks ago and they've just never shut it down because it takes so long to get it going.
Yeah.
They just leave it there. But you know, you can go to Safeway and for 30, 40 bucks you can buy an Android phone and develop on that. So if you're trying to do this, right, I recommend actual physical hardware. So we're going to use a Samsung here. So we'll say OK. And keep your eye on this, right? That tells you that it's doing something. You don't really want to interact with it while it's doing something. There's also a message here in the middle, Gradle build running. But this bar down here tells you things are happening.
pulling while you're starting.
And meanwhile, let's look at our phone. That little light up there is invisible when I look at it, but you can see it on the document scanner.
It's interesting and somewhat creepy.
So
Yeah.
somebody's watching you?
Yeah, that's the proximity sensor, I believe.
If you look, it actually worked.
All right, so there's our application running, and it says "Hello World," and it's kind of fuzzy, but
Is the font based off of your system on the phone?
oh yes, yeah, I have a weird italic font built in. So it's a super cool project, and there's a hello world, right? So, and we can go back
That's
home.
pretty good.
And I got an icon for it, so I can click on that, and there's hello world. All right, so this is the design window version, right? So just like with Window Builder, we've got the text, which is XML, and we can go to design, and it shows us a visual layout of our application. And this is what it's actually going to look like when it runs. So there's the title, and there's the hello world down there. And this is, I don't know what the right side is. You can make it go away, but I leave it there. It's another view of how that display is being made. So if I click on this, we can see it's a text view, okay, because it's telling me text view. And over here in the upper right, we can see, for example, what the text is. So I can change the text and say, surrender all hope. Hoopy. Right, so now that's what our application will look like. And if we want to try that, we can just say run app. And it shouldn't take as long to get going this time. Probably about half a minute. So there you go. Surrender all hope. All right, let's do something different though. So I'm just selecting that object, and then I hit delete, and that got rid of it. So now we've got a totally empty window here. So what do we have to work with? We have buttons, toggle buttons, checkboxes, radio buttons, spinners, progress bars, right? All these kinds of widgets that we've seen before. Various forms of text. So a text view is just a way to display text. There's plain text. There's a password field where we can type in, and it'll show us little dots instead of our letters. Emails, phones, number fields, etc. There's layout editors. So table layout, grid layout, and so on. Scroll views, web views, right? So containers that we can put around things. And these are analogous to the things we've been playing with in Swing or in Java in general, right? Different kinds of widgets that will do different things, and they're all documented. So we can pick a web view.
This emulator is using 65% of my CPU.
Cool.
I don't know how people just have it sitting there.
Yeah. So you can Google WebView Android, and Android developers is a good source of documentation. Here's the documentation on the WebView class, right? And this looks familiar, right? This is similar to the Java doc that we've been looking at all quarter. So here's WebView, and it's an extension of an absolute layout, a view group, a view, and it's ultimately an object. And there's some wordage about it. And if you scroll down a little bit, or a lot bit, there's constructors. So these are the different ways you can construct a web view. And there's a list of methods, right? And everything is hyperlinked, so you can follow the chain of everything is hyperlinked. Hello. Or not. It's trying. Yeah, I gotta speed.
Were you just,
You're
It's just Android as a whole. Some of that.
Yeah.
were you
This-
still on the internet?
Well, I just got to this page, so presumably,
Oh, yeah.
but let's try. Well, I may have lost my net connection, which is going to be a problem. So let me try my email.
Which is gonna be a problem.
Yeah, because I think some of the stuff you do in Studio does want a
Yeah,
connection.
I wasn't connected to the internet, and when I started this project, it threw all kinds of errors.
Yeah.
Yeah, I'm
And then,
curious,
so then when I connected to the internet, then it fixed all of it, so.
how familiar are you with Gradle? Because it seems to be a tripping block.
Yeah, what is even this?
everywhere.
I cannot define Gradle for you. Yeah, I need to log in again. Nope, it got it.
Gradle breaks a lot of things.
Yeah,
I just don't
alright.
understand why it's so like extensive, it's so slow and like, I don't know, heavy for your system.
Yeah.
I don't know what it's doing, that's so complex.
Is that almost
I don't know,
like
but it's
for-
doing a lot. Alright, so everything is hyperlinked. Alright, so where were we? Alright, so we have different kinds of widgets we can drag and drop into our layouts. Let's drop a button down here. So we'll grab a button and we'll bring it in here, and there's a button. Alright. So we can run this, but it's not going to do exactly what you want. Give it a second to come up.
This is, I think, where we found that it diverts significantly from Swing and Window Builder,
Mm-hmm.
and that in Window Builder, you have your form, and it, like once you create a button, it's reading from the code and creating your layout,
Mhm.
and vice versa. So it creates all these buttons and it creates all these functions for you. But in this, you have to define exactly what it's going to do.
Yes, yes.
And that's the frustrating part, is like trying to figure out exactly where you put those things.
Yeah.
Like your action listeners.
So we'll
Yeah.
we'll get there.
I found like in the XML, I think that was part of it, like you actually have to call the function there.
Yeah.
I don't know.
So we tried to put a button kind of in the middle of the screen here, and when we run the app, the button's sitting up here in the upper left corner, right? So this can be frustrating in itself. So the default layout manager is not absolute, even though it looks absolute. It looks like I can just drop this wherever I want,
The warning right there also
Right.
says that.
but this view is not constrained. Okay, so it will jump to 0, 0 unless you add constraints. Okay, so constraints are basically pinning this thing to different locations on the screen. So if we want to pin this right here, here's an easy way to do it. Come to this little circle on the left, left click and hold, and draw an arrow to where you want it to be constrained to. Okay, now it's in some sense anchored to the left side, and if I drag it, it extends this and it says, okay, this is going to be 124 pixels from the left edge. And I can do the same thing on the top, and now I've got it anchored. And now if I run this, it will leave it right where we tried to place it. Who knows why that suddenly popped up. Alright, so there's our button. And we can click this button, and you can see it kind of getting dark and getting light again, right? But it doesn't do anything, obviously, because we haven't told it what to do. But we'll fix that presently.
You could make a clicker game out of that.
We could. We could make Cookie Clicker.
Yeah, and just post that, like it's in a minute, like a web page and see, keep it. World champ at clicking. Look at your pick on one of those really
Alright, so I'm going to drop over this plain text widget. This is an edit text object, okay? And it's also not constrained, so I'm going to tie this to the top of the button, and I'm going to tie this to the left, and I'm just going to place this right here. And if I click on this, right, I can see its name is edit text. The text in there is name, so I'm just going to change this to hello. And so let's name these things. Instead of calling this button button, let's call it go. And instead of calling this thing, yeah, whatever. Let's call it go, and let's change it to, say, click me. And this box up here, instead of calling it edit text, let's call it message, MSG. All right, so we've got the basic layout of our application, right? And every time that we move these things around, it's updating the XML. So it's added an action area for button. Do people know XML? Extensible markup language. So it's kind of like HTML, but it's generalized. So everything is surrounded by angle brackets. And so here's a button, right? And it contains different fields. Android ID is ID/go. Android layout width is wrap content, etc., etc. The text is click me, and so on. And then when you have a backslash followed by an angle bracket, that's the end of the button definition. And you can embed these things inside other. And there's nothing in XML that says what any of this means. Okay, it's really just a format for describing things in this language. But lots of different things use XML as a language for describing different kinds of data. So this is how the layout is recorded and modified. So if we change this field right here to something, it'll change in that button label. Yeah.
You basically like construct objects out of that?
We will, right? So when things get built up, it will use this to say, for example, I want I want an object called message, right? And it's going to say hello, and it's going to be located this far from here and this far from there, and so on.
Yeah, much the same way that HTML, you used to use tables to do
Yeah.
everything. XML does the same thing
Mhm.
for applications.
Right,
Well,
right.
it does it elsewhere too. It's like basic table
Yeah.
language.
All right, so that's writing XML. We can work with this ourselves, but for this case, we're not going to. We're just going to work with the layout window, okay, kind of like window builder. You can monkey with this. You got to be careful what you're doing, right? There's lots of tutorials on how to work with this directly, and a lot of people totally shun the layout window because you just have more direct control with this. But I'm not one of those people, so I'm just doing the drag and drop. All right, so there's our window. That's what it's going to look like. But if we run this, it'll show us our window in a second, but it won't really do much.
Does it automatically pop the app up on there?
It did for me. It didn't earlier on another phone I was using. But it'll show up in your list of applications. I think I have something set on here that when something gets installed, create an app.
Oh, okay.
Create an icon. All right, so there's our application. We can still click, but it doesn't do anything. But this is an editable window, so we can type in here, right? So we got to put some code in to actually work with this. But this is our framework of widgets. All right, so let's take a 5-minute break. This is a good pausing point. And we'll come back, and then we'll make the button do something, and then we'll play with that.
Do you know what those errors are?
What errors?
Probably set default message